So first, let's look at the R format. The general format is that we have an operation and we have two registers. So examples of that is, for example, add. If you remember, we had something like S0, S1, S2, or subtract, or add unsigned and subtract unsigned. So we have, these are the examples. So if you notice, all of these, they have the same pattern. They have an instruction or operation, and they have two registers. And all of them, we said that, so if you have something like that, the operation gonna act on these two registers, and then the result is going to be into the first one. So all of them follow the same, exact same format. So we call this R format or register format because we have the three registers. Here is a special case R format instruction. So you see normally the R format instruction had three different registers. So it had the operation and then two registers in front of it. So here we only have two registers. And what is happening that one of them is actually not set. So the result of the operation, here the multiplication operation between these two, is going to two special registers. And that is actually by design because when you are multiplying two 32-bit number, you are going to get 64-bit of result. And basically that's going to be size of your output. And how the MIPS processor handles this is to take the lower 32 bits on the low register. So here, if that is your whole 64-bit answer, the lower 32-bit of your answer is going to the low register, which is a special register. And the higher 32 bits of your answer is going to the high registers. So in that case, you can access basically all the bits of your answer. And we have four special instructions for these to basically take read data or write data from low and high registers. And these are basically, for example, this one is moved from high, and that means it's gonna take the data that is in the high register and put it to the RD or the register that you are specifying. If you have moved from low, it is going to take the data from the low register and put that in the register that you give it to. But also we have basically move to high and move to low, which works in the opposite direction. So you take some registers data and you put that in the high registers. So these four are special for that two register that we have. So here is another example of the difference between assembly language and machine language. So here, for example, if you are doing a multiplication, you can actually convert this based on what we just learned to these two instructions. And it is going to basically calculate your answer as you expect. So if you are doing basically multiplying 22 and 21, or register 22 and register 21, and you are storing the answer into register 23, what actually happens is that, and that's again depending on the design of the processor. These are very specific to the design of the processor. But what could actually happen is that we have a multi instruction that is taking these two, calculating that 64-bit result, and then you have a move from low and take that answer to your register 23. So basically we are using this part of the answer, and we're gonna put that in our destination. So this is a good example of how basically you can have different instruction in assembly, and when it's converted to machine language, in some cases, it could become two separate instructions. And this could be also basically reused from different things. So in this way, like on the design of the processor, there are some um, there are some like basically efficiency of sharing few instruction between more assembly instructions, and basically those are gonna um, get assembled and those gonna be converted to those fewer instructions, and that simplify the design. So we are going to see another examples of this in the next slides.